Looking at centripetal force. Centripetal force is the force that keeps an object traveling in a circle. So sometimes it'll say centripetal force, sometimes it will say the tension on a string or the friction on the road. Anything that is keeping that car or that object from flying off the track is your centripetal force. And when we're calculating it, the equation that we use is Fc equals mv squared over r, where the centripetal force is found by taking the mass in kilograms times the tangential velocity in meters per second. That's just how fast it's going around the track or the corner or the curve or whatever it is. And then divided by the radius, and that's measured in meters. So an example to this would be a 700 kilogram car drives in a 20 meter radius circle at a speed of 16 meters per second, and you're going to calculate the centripetal force. So when we're doing that, we have our variables here. We have 20 meters for our mass, which is 20 meters for our radius, which is right here. Mass is 700 kilograms, velocity is 16 meters per second, and we'll solve for Fc. We don't need to rearrange this one. So we have Fc equals mv squared over r. So we're going to take our mass of 700 kilograms times our velocity of 16 meters per second. We'll square that number there, only that number, and then divided by our radius of 20 meters. And when we do that, we end up getting, we take 700 times 16 squared divided by 20, and we get 8,960 newtons. That would be our centripetal force. In this case, we would have friction providing that, keeping the car from flying off the track. Another example would be one where we have something where we have to rearrange it. Many times we have an equation, but it's not arranged to solve for what we need. So in this situation, we have a 1,200 kilogram car, that's our mass, driving at 12 meters per second, that's our velocity, and it has a force of 2,160 newtons holding the car on the curve. What is the radius? So we're going to solve for radius here. We have the equation that Fc equals mv squared over r, and so we need to get r by itself. It can't be on the bottom. So since they're dividing by r right now, the first thing we need to do is multiply by r. If you take anything divided by something and then multiplying by it, it cancels it out. So I have r times Fc equals mv squared. I'm still trying to solve for r, but now it's up top, so that's helpful. I need to bring the Fc over to the other side. Currently, we're multiplying by it, so I'm going to do the opposite. Divide by Fc, divide by Fc, cancels that out. So I'm left with the equation that r equals mv squared divided by the centripetal force. Well, I have all of those pieces. The mass is 1,200 kilograms. The velocity is 12 meters per second, and I'm going to square that, divided by the centripetal force of 21,060 newtons. When I take and calculate that in my calculator, I put in 1,200 times 12 squared divided by 2,160. You should get 80 meters for your radius. So sometimes you'll need to work through and rearrange. Remember when you're rearranging to figure out what you need, and do the opposite to keep bringing it over there.